Alright, in this video we're going to examine proportional relationships in tables and graphs. Alright, so for a proportional relationship, the keyword is constant, right? And that means to never change. So in tables, what we should look for is that all k equals y over x are equal, and we should remember that k is called the constant of proportionality. And in graphs, it either has to be linear, which means a straight line, and, don't forget the ands, all lines touch the origin, 0, 0, or point towards the origin. In a non-proportional relationship, which is basically the complete opposite of what we just said, in tables, not all k equals y over x are equal, and if they're not equal, then it's not called k. And in graphs, it's either not going to be linear or does not pass through the origin or point towards it. All right, so the first question we're going to look at is ratios and proportions. Well, worksheet number 9, the homework question. All right, so Gabriella pays her cell phone bill every month. For each hour Gabriella talks on the phone, an additional cost is added to the cell phone bill. The graph below shows her cell phone bill for the amount of hours she spends talking on the phone. All right, so here's our graph. We have the cell phone bill, the x-axis being the number of hours, and the cost being the y-axis. All right, so part A tells us to complete the table below using the graph. Well, if we look where the hours are 0, we're going to have 10. If we look where the hours are 1, we have about 11. Where the hours are 3, 13. Where the hours are 5, 15. And where the hours are 8, we have about 18. All right? And just remember that we read points x, y, where x is the horizontal direction and y is the vertical direction. Just by looking at this graph, we could tell that it's not proportional. So in graphs, it's not linear or does not pass through the origin or point towards it. So when looking at this graph, it's linear. It's definitely linear. However, the origin is right here, and the graph doesn't point towards it, or neither does it pass through it. All right, so let's move on to part B. So how much does Gabriella pay for talking on her cell phone for 0 hours? Well, for 0 hours, we found that she pays $10. Part C, for the cost you found in part B, what is a possibility for this cost? And if you remember from class, we said that a possibility for this cost is an enrollment fee, a signing fee, something like that. So you have to pay, a certain amount of money just to get the service to begin with. Maybe she went over her minutes, something like that. And that's, all right. And D, does this graph have a constant of proportionality? Well, we said that a graph only has a constant of proportionality if it is proportional. We already said that this graph we said that this graph is not proportional, therefore it shouldn't have a constant of proportionality. All right, so this graph does not have a constant of proportionality. And if we were to actually test it, right, by looking at our points, we have 0, 10, which is right here. And if we create another row for k, which is y over x, these all need to be the same in order for there to be a constant proportionality. All right, so I'm gonna do the work down here. So y is the cost x is the hours. So for the first one, we're going to have 10 over 0. And we can't divide by 0, so this is undefined. For the next column, we have y is 11, x is 1. This is going to be 11. All right, so we could stop here and say that, not all y over x is the same. We have one that's undefined, and the other one's 11. So therefore, it's not proportional, and there is no constant of proportionality. All right, and we could go on 13 over 3. That's going to give us 4 1/3. For the next one, 15 over 5, we get 3, and 18 over 8, that equals 2.25. All right, so here's all our values for y over x. We got undefined, we have 11, we got 4 1/3, we got 3, and we got 2.25. All right, so they're not all the same. If they're not all the same, there is no constant of proportionality, and therefore it's not proportional. All right, so let's look at some more table questions. Question 1. A scooter's speed is recorded at specific times. Does the scooter's speed represent a proportional relationship? Justify your answer. Well, let's create another column for k. And if we go back to our notes before, in order for there to be a proportional relationship in tables, all k equals y over x needs to be the same. All right? And if it's the same, it's called the constant of proportionality. If it's not the same, there is no constant of proportionality. So, k. This one's going to be 5 over 1/2. That is 10. The next one we have 10 over 1. That's 10. And for the last one, we have 50 over 5, which is 10. All right, so they're all the same. Therefore, k equals 10. And therefore, the constant of proportionality is 10, and this graph is proportional. And the reason would be because all y over x is the same. For part 2, or question 2 rather, Santa conducted an experiment to determine how much weight his reindeer could carry. The results of his experiment are depicted in the graph below. Is the relationship proportional? Justify your answer. All right, so once again, create another column for k. For the first column, we're going to have 100 over 2. That is going to be 50. For the second column, we have 200 over 5. That is going to be 40. And the last column, we're going to have 300 over 6. And that is 50. All right, so we have 50, 40, and 50 again. So even though two of them are the same, we got one that's not the same. Therefore, this graph is not, this table is not proportional, and there is no constant of proportionality. All right, that would be your reason. All right, thank you for watching. Stay tuned for the next video.